Okay, section R1 is Prealgebra review. So before we get into it, we're going to be dealing with and referring to a certain set of numbers called the natural numbers a lot. We'll get into more sets of numbers in a little bit, but the natural numbers are what we also call counting numbers. They're the numbers 1, 2, 3, 4, 5, 6, 7, and so on. So they are positive whole numbers. Okay, so we'll start with fractions for this section. So fractions, a fraction, I'm sure most of us know a fraction is just a number that represents a part out of a whole. So the part is the numerator and the whole is the denominator. So for example, if we have 2 over 5 right here, the 2 is the numerator. It's the part out of the whole, which is the denominator, which is 5. So we can read this as 2 over 5 or 2 fifths is even better. So 2 over 5 or 2 fifths, which is just 2 divided by 5. Okay, another way we can represent numbers using fractions is mixed numbers. So a mixed number is going to be the sum of a natural number and a fraction. And this is expressed without the use of an addition sign. So we have 3 and 4 fifths. So this actually equals 3 plus 4 fifths. And just like I read it right now, you read that as 3 and 4 fifths. So usually not really going to be using this notation a lot, but it is important because it does pop up a lot in other disciplines. So that's a mixed number. We have the natural number and a fraction. So the next one is an improper fraction. So an improper fraction is when the numerator is greater than the denominator. So numerator greater than the denominator, that's called an improper fraction. So something like 19 over 5 is an improper fraction because the numerator 19 is greater than the denominator 5. So conversely, if we have the numerator less than the denominator, like we do up here for 2 fifths, that is called a proper fraction. So there's actually nothing wrong with improper fractions. That's just the name for them. Okay, so let's do some conversions here. So let's convert from a mixed number to an improper fraction. So to do this, the first step is we're going to multiply the denominator of the fraction by the natural number out front and add it to the numerator, or add the numerator to that product. We're going to place that result over the denominator from the original fraction in the mixed number. Okay, so for example, let's convert the following mixed numbers to improper fractions. So we have 3 and 4 fifths. Okay, so what we're going to do, based on these steps, we multiply denominator and the natural number, add it to the numerator, and then place it over that denominator. So this is going to be 5 times 3 plus 4. So 5, the denominator, times the natural number out front, plus the numerator, all divided by the original denominator. So obviously we have to simplify this. This is 15 plus 4 over 5. So this is equivalent to the improper fraction 19 over 5. So this is 19 fifths. So 3 and 4 fifths is the same thing as 19 fifths. So we'll kind of see why we do these steps when we get to actually adding fractions. Okay, for the next one we have 2 and 3 fourths. So it's going to be denominator times the whole number out front, natural number out front, plus the numerator, all over that denominator. And just kind of just recall that the little dot is another way we can represent multiplication. So 4 times 2 is 8, plus 3, over 4. So this gives us 11 over 4. So 2 3/4 is the same as 11/4. And for the next one, so what I'm going to do here is we have negative 5 5/8. We do this the same exact way. You can kind of ignore the negative for now and just put the negative back in for your final answer. So what I'm going to do, just to be mathematically correct here with putting an equal sign, I'm going to put a negative out front. So negative, and now it's going to be denominator times natural number plus the numerator, all divided by that denominator. So this is going to be 8 times 5 is 40 plus 5 over 8. This gives us negative 45 over 8, so negative 45/8. Okay, so that's how we go from a mixed number to an improper fraction. So now let's go the other way. Let's go from an improper fraction to a mixed number. Okay, so to do this, we're just going to divide the fraction. So that's what fractions technically mean. It's just division. So we're going to divide the improper fraction, and we're going to record the quotient, which is the answer, and the leftover, which is the remainder. So once we do that, we're going to write the mixed number using this following form. The quotient is going to be the natural number out front, and it's going to be the quotient and the remainder over the original denominator. Okay, so for example, let's convert the following from improper fractions to mixed numbers. So we have 42/5, 42 over 5. So what we can do here is we're going to do 42 divided by 5. So we're going to divide it. So 5 goes into 42 8 times. We multiply 8 times 5, we get 40, and then we subtract, and we get 2. So now 2 is less than 5, so we can't divide anymore. So this actually gives us our answer. We have the quotient right here, and this right here is the remainder. So our answer is going to be, the quotient is 8. So 8 and 2/5. So put an equal sign here. So 42 over 5 is the same thing as 8 and 2/5. The quotient and the remainder over the denominator. Let's do another one. So 36 over 7. So we're going to divide it again. So 36 over 7. So 7 goes into 36 5 times. 7 times 5 is 35. Subtract, we get 1. And there's the remainder. So 7 can't go into 1 anymore. So we have our final answer is going to be, the quotient is 5 and the remainder over the original denominator, so 7. So 5 and 1/7. So 36/7 is the same as 5 and 1/7. And then we have negative 52/4. So once again, I'm going to ignore the negative and divide it. So 4 goes into 5 once. Multiply, subtract, bring down. 4 goes into 12 3 times. It actually goes in evenly, and we get 0. So we have a remainder of 0. So what we can do here when we write this, if we were writing this as a mixed number, I'm going to bring that negative back in. It's going to be negative 13 and 0/4. That's kind of silly. We wouldn't write it like that. We would just write negative 13. So our answer here is just negative 13. So negative 52 over 4 is just negative 13 because 52 over 4 is just 13. Okay, so that's converting between mixed numbers and improper fractions. Let's move on to the next thing. So the next thing is factors of a number. So this is actually a concept that's really important. we'll be getting to factors of variables later on, but factors of a number is first. So factors of a number, factors are numbers that multiply to that number. Okay, so factors are being multiplied to something else. So factoring something, in this case factoring a number, means to rewrite it as the product of two or more other numbers. Okay, so let's, before we kind of get into that, let's do these examples. So let's list all of the factors of the following. So let's list the factors of 21. So we want to say, okay, what numbers multiply to 21? Well, we can either have 1 times 21 or 3 times 7. So the factors of 21 are 1, 3, 7, and 21. Okay, so there's 4 factors of 21. Let's see what the factors of 30 are. So for 30, we can either have 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So you can probably see how I'm kind of putting this in order here to help me do it. So these are all the factors of 30. So listing them out, we have 1, 2, 3, 5, 6, 10, 15, and 30. That's a decent amount of factors for 30. Okay. Oops. And next, for the factors of 16, we think about the numbers that multiply to 16. We have 1 times 16, and 2 times 8, and 4 times 4. So that means the factors of 16 are 1, 2, 4, 8, and 16. So notice that I only wrote the 4 once, even though 4 times 4, we have it written twice on the right side. But you only need to write it once, you don't need to repeat it. And lastly, the factors of 13 here. Factors of 13, just 1 times 13. So 1 and 13 are the only factors of 13. Okay, so we see that the factors of 13 are just 1 and itself, which brings us into this next concept of prime numbers. So prime numbers are just natural numbers greater than 1. So 1 is not a prime number. So a prime number is a natural number greater than 1 that has only itself and 1 as factors. So examples of prime are 2, 3, 5, 7, 11, 13, 17, 19, and so on. So this is because 2 times 1 is 2. That's the only factors of 2. 3 times 1 is 3. Only factors of 3. And I'll just kind of put ... So the only even number that is also a prime number is 2. So 2 is kind of special in that case. And just keep in mind once again that 1 is not a prime number. And then next for composite numbers. So composite numbers that are numbers greater than 1, once again. So 1 is neither prime nor composite. A composite number is just a number greater than 1 that's not a prime number. So examples are like 4, 6, 8, 9, 10, 12, 14, 15, etc. So every even number other than 2 will be a composite number. Okay, so that's because for a number like 4, we can have something like 2 times 2 is 4, and 2 times 3 is 6, 2 times 4 is 8, and so on. So those are not prime because those are different factors other than 1 and itself. So hopefully pretty simple concept there. So let's use this concept from the last couple of pages here and do some prime factorization. So prime factorization is using the fact that every single composite number can be expressed as a product of prime numbers. So expressing a composite number as the product of prime numbers is called the prime factorization of that composite number. Okay, so for example, let's say we had the number 16. So 16 is the same thing as 2 times 2 times 2 times 2, right? If we multiplied those together, that would give us 16. So we actually call this the prime factorization of 16 because 2 is a prime number. So 2 times 2 times 2 times 2 is the prime factorization of 16. Product of prime numbers. So the way that we're going to do this, I'm kind of going to have it set up as like a little tree. We start by selecting 2 factors of the original number, and if one or both of the factors are not prime numbers, we continue by keep on factoring each composite number, and then we stop when each number is prime. Let's do an example. So let's find the prime factorization of the following. So let's say we have the number 100. So I'm going to do this like this, little tree. Okay, so 2 numbers that multiply to 100. There's not always going to be one way to do it. We can do 2 and 50. So 2 is prime, so I'm just going to circle it just so we know that we're done on that side. For 50, we can do 5 and 10. 5 is prime, so I circled it. And then for 10, we can do 2 and 5. 2 and 5 are prime, so we're done with those. So we can say that 100 equals 2 times 2 times 5 times 5. That's the prime factorization of 100, and you put them in ascending order just to make it keep some order to it. So the next one for 36. So 36, make little branches. So we can rewrite this as 2 times 18. You could have done other factors also. You could have done 6 and 6. So 2 is prime, so I circled it. 18 factors to 2 times 9. And then 9 factors to 3 times 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. And then next for 94. So doing the prime factorization for 94. So it's obviously a little bit larger here. We know it's even. 94 is an even number. So we know 2 goes into it. 2 times 47 is 94. So when we think about numbers that factor or that multiply to 47, 47 is actually prime, so we're done. So the prime factorization of 94 is 2 times 47. So there's an infinite number of prime numbers. So it's sometimes hard to recognize when the numbers get larger if they're prime or composite. Okay, we're going to use this concept to help us do the next thing, which is simplifying fractions. So simplifying fractions is also called reducing fractions. So fractions can be simplified. The way that we're going to do it is by first factoring the numbers in the numerator and denominator separately. And then what we're going to do is cancel common factors. So a fraction is considered simplified when the numerator and denominator have no common factors other than 1. So the way that we can think about this is dividing off common factors in the numerator and denominator. Okay, so let's do these examples. So we have, for example, let's reduce each fraction to lowest terms. So we have 4 over 6. We have 4/6. So I'm going to use the prime factorization technique here. We can rewrite 4 as 2 times 2. We can rewrite 6 as 2 times 3. Now we can cancel common factors. 2 divided by 2 is equal to 1. So that means we're just left with this 2 over 3. So 4/6 is the same thing as 2/3, except 2/3 is in lowest terms because 2 and 3 don't have anything any factors in common other than 1. Okay, let's look at 6/14. So for 6/14, we can rewrite 6 as 2 times 3 again. We can rewrite 14 as 2 times 7. We can cancel off common factors of 2 because it equals 1. And we are left with 3/7. So 6/14 is equal to 3/7. 3/7 is reduced. Okay, for the next one, we have 15/75. So for 15/75, what I am going to do here is I'm putting a little bit of forethought into it. I'm going to leave 15 as it is, which you don't have to do. Little bit of forethought. 75 is the same thing as 15 times 5. So we can cancel off common factors of 15, but just remember that when we do that, we're left with 1/1. So it's 1/1 times 5, so just 1/5. You could have done it the other way and rewrote 15 as 5 times 3, and rewrote 75 as 3 times 5 times 5 would be fine, but this is 1/5. Okay, so I'm going to do these last two just a little bit differently. I'm going to do it using that technique where we think about it is dividing off common factors. So for 11/33, we're going to divide both of these by 11. This is when you just have to recognize what the factor is that you're canceling off. 11 goes into 33, so I'm going to say, well, let's divide the numerator by 11 and the denominator by 11. In the numerator, 11/11 is 1, and 33/11 in the denominator is 3, so that's just 1/3. So both techniques are technically the same thing, same concept for the most part. They're both going to get you the right answer as long as you do it correctly, obviously. Okay, and then for the last one down here, we have -60/10. So I'm going to recognize that 10 goes into 60. And I'm going to say let's divide the numerator and denominator by 10. The negative's kind of coming along for the ride. 60/10 is 6. 10/10 is 1. So we have -6/1. We don't want to write it like that. Anything over 1 is just whatever the numerator is, so it's just -6. Which hopefully we knew just looking at it, 60 divided by 10 is 6. Okay, so that's simplifying fractions. So let's do some multiplying fractions next. So multiplying fractions, when we're multiplying fractions, we're going to multiply the numerators together, and then we're also going to multiply the denominators together. So what we're going to have is if we have, let's say, a/b times c/d, this is going to equal a times c in the numerator divided by b times d in the denominator. So that's just multiplying numerators together and multiplying denominators together. And then obviously we're most likely going to have to reduce the lowest terms. So it's good to keep in mind here, a positive times a positive is a positive number. A negative times a positive is a negative number. And a negative times a negative is a positive number. And also with this little note here, this little note right here, we have, if we have negative x, that just equals x. So that's saying like -1 times a negative number, the negatives cancel out to a positive. Okay, so let's multiply these together here. So for these examples, for the first one, we have 3/7 times 2/5. Okay, so what we have, what is going to be best for you to do is simplify it if you can before you multiply the numbers. So we could write it like this: numerator times numerator over denominator times denominator. Those are all prime numbers. We can't factor any of those numbers anymore and cancel common factors. So let's just multiply them and get our final answer. That's going to give us 6 over 35, and that's our answer. Okay, let's do the next thing. So 5 times 7/12. So we have to use the fact that 5 is just 5 over 1. Okay, so make sure that you're not accidentally multiplying 5 to numerator and denominator in 7/12. So you have to rewrite it as 5 over 1. Okay, so I'm going to rewrite this as 5 times 7 over 1 times 12. I'm going to factor that 12 as 4 times 3. 4 can be written as 2 times 2. I'm going to leave out the 1 because that won't change anything. So essentially I just rewrote 12 as 2 times 2 times 3. The only reason I did that was to see if we can cancel any factors, which we cannot. Those are all prime numbers now. Nothing cancels in the numerator and denominator. So now we can multiply. Now we can multiply, and we get 35 over 12. So if you recognize that things won't cancel, you don't have to do each and every individual step. The goal for this is to kind of not have to do that, but just so you know how to do it for now, that's how we're going about it. Okay, so 4, and also keep in mind here, we're not cross-multiplying. If you remember anything with cross-multiplying, we'll be getting into that. That's something completely different. So for this next thing, we have negative 2/3 times 9/4. So I'm going to leave this negative out front and make it 2 times 9 divided by 3 times 4. So I'm going to rewrite that 9 as 3 times 3. I'm going to rewrite that 4 in the denominator as 2 times 2. Just once again, factored these. And I did that because now we can see they cancel. So we have a 2 over 2, and then we have a 3 over 3 that cancel. And we are left with the negative 3 over 2 is our answer. So once again, you could have multiplied straight across and gotten negative 18 over 12 right away from the beginning, but you would have to simplify that. So whichever way is easier for you and quicker for you is fine. Okay, so for the next one, we have 3 2/3 times 1 1/4. So you can probably see the difference here. We have mixed numbers. When we're multiplying mixed numbers, we have to convert to improper fractions. So we have to do this every single time. So 3 2/3, I'm just going to do this kind of pretty quickly. 3 times 3 is 9, plus 2 is 11. So that equals 11/3. 1 1/4, 4 times 1 is 4, plus 1 is 5. So 5/4. So this is going to give us, put a little forethought into it. I know that nothing's actually going to cancel because the only composite number here is 4, which is 2 times 2, which won't cancel with anything in the numerator. So I'm just going to multiply straight across and get 55 over 12. And that's the answer. You could convert that back to a mixed number if you want. I'm just going to leave it like that for now. Okay, so let's do several more. It's a pretty important concept that people tend to forget how to do, so make sure that we're good with it. So we have 4/11 times 2/3. So once again, kind of know that nothing's going to cancel because in the numerator, 4 is the only composite. It's not going to cancel with anything in the denominator. So I'm going to multiply straight across and get 8 over 33. And for the next one, we have 6 times 3/5. Once again, 6 is 6 over 1 times 3/5. So nothing, once again, is going to cancel because we have 1 and 5 in the denominator. It's not going to cancel with anything from the numerators. We're going to get 18 over 5. For g, so we have a negative times a negative for g. So we know the answer is going to be positive. So I'm actually going to just take that into account right now and just kind of ignore those negatives. So we're going to have This is the same as 3/7 times 1/3. Just kind of drop those negatives. So right now, before combining this into one fraction, I'm just going to put a little forethought into it and say 3/3, those are going to cancel, and we're just going to end up with 1/7. So just remember that once again, when we cancel off factors like that, when we're dividing, technically there's a 1 left. So it'd be 1/7 times 1/1, which is just 1/7 times 1, which is just 1/7. Okay, last one here, mixed numbers again. Convert to an improper fraction. So 3 2/5 is an improper fraction. 5 times 3 is 15, plus the 2 is 17. That's 17/5. And for 1 1/2, 2 times 1 is 2, plus 1 is 3, over that 2. So we have 17/5 times 3/2. So put a little forethought into it again. Nothing, these are all actually prime numbers, and none of them are going to cancel with each other in the numerator and denominator. So multiply straight across. 17 times 3 is 51. 5 times 2 is 10. So 51/10. Okay, so that is multiplying. That's multiplying the fractions. So next for dividing. So for dividing fractions, it gets a little bit trickier. So dividing fractions, we need to understand this concept, the reciprocal. So this term is very important, and the idea of it's very important. It comes up all the time. The term comes up all the time, so make sure you know what the reciprocal means. The reciprocal, another name is the multiplicative inverse, but we'll just be calling it the reciprocal. So the reciprocal of a number, the reciprocal of a fraction, if the fraction is a over b, the reciprocal is b over a. So you can kind of think of it like flipping the numerator and denominator. I put flipping in quotes because those types of words in math are just not that good. But you can think of it that way. We're just flipping the numerator and denominator. So reciprocals have a product of 1. So if we multiply them together, we get 1. So the way that we're going to be doing this when we're dividing fractions, the quotient, so quotient is just the answer for dividing. The quotient of two fractions is the first fraction multiplied by the reciprocal of the second fraction. So we're going to be changing division to multiplication and then multiplying the same way we just did it. So the way that you can kind of remember this is you keep the first fraction the same, change division to multiplication, flip or reciprocate the second fraction. And the phrase that gets used all the time is keep, change, flip. Because we keep, change, and flip. Let's do these examples. So let's divide these fractions and then simplify it if we can. So pretty much we should always be simplifying or reducing fractions if possible. Let's do this first one. So we have 2/3 divided by 7/15. So we see that it's division. So we're going to keep the first fraction the same, change to multiplication, and reciprocate the second fraction. So keep, change, flip. And now we do it the same way we just did it. So 2 times 15, I'm going to use the fact here that I'll combine them just so I'm not skipping too many steps. I'm going to rewrite 15 as 3 times 5. And I did that because then the 3's cancel. Now we can multiply 2 times 5 is 10 over that 7, and we're done. So 10/7. So next we have 3/4 divided by -5. So we're dividing, so let's keep, change, flip. Before we do that, actually, what I'm going to do is I'm going to rewrite -5 as -5/1. Okay, and we just have to, same rules apply with negatives for multiplying as well as dividing. So our answer is going to be negative here. So now I'm going to keep, change, flip. So keep the first one the same, change the multiplication, and reciprocate the second one. So the reciprocal of negative 5 is negative 1 over 5. And now I'm going to multiply straight across, knowing nothing's actually going to be canceling here. So we're going to get negative 3 over 20 is our answer. Okay, and the next one we have 4 3/4 divided by 1 1/2. Once again, we have to change these to improper fractions. So as an improper fraction, 4 3/4. 4 times 4 is 16, plus 3 is 19. And then changing 1 1/2, 2 times 1 is 2, plus 1 is 3, 3/2. So now we can do keep, change, flip. Keep the first one the same, change the multiplication, reciprocate the second. So 19 times 2 is 38. Oops, I'm going to, before I do that, I'm going to actually cancel some common factors. So 19 times 2, combine it into one fraction. I'm going to rewrite 4 as 2 times 2. And I did that because now we can see that that 2's cancel. And we're left with 19 over 2 times 3, so 19 over 6. Let's do a couple more. So 5/4 divided by 3/8. So keep, change the multiplication, reciprocate the second. So I'm going to simplify this one a little bit differently. So I'm going to do just, if you want to do it this way instead. You might see now that 8 divided by 4 is they're going to cancel a common factor of 4. What you could do is say 8 divided by 4 is equal to 2. And write it like that. And there's just a 1 left over down here. So we're left with 5 times 2, which is 10. 1 times 3, which is 3. So if you don't like it that way, you don't have to do it that way. But if you do, then definitely do it that way. It's probably a step or two shorter. So for the next thing, we have negative 2/3 divided by negative 3. So what I'm going to do is recognize that negative divided by negative is positive. And I'm going to kind of get rid of those negatives then, ignore them. And I'm going to rewrite 3 as 3 over 1. So we have 2/3 divided by 3 over 1. So keep, change, flip. And we have 2/3 times 1/3, multiply across, that's just 2/9. So that's our answer. Okay, so far we've done we've done multiplying and dividing. So next we're doing adding and subtracting. So you would think that maybe we would have done adding and subtracting first because that's usually easier, but we are doing that last because it's actually a little bit harder for fractions. So for adding and subtracting fractions, we have to have a common denominator. That's the only way we can do these. So once they do have a common denominator, we add or subtract the numerators and place them over that common denominator. So if we have a over c plus b over c, so two fractions, same denominator of c, whatever the heck that is, we end up getting, we add the numerators and place it over that denominator. So we do not add denominators or subtract denominators. Very important. Okay, so when we start with common denominators, it's a little bit easier. We don't have to adjust the expression at all. When they're not the same denominator, we have to find common denominators. And what we're going to do is we're going to find the least common denominator, because that's going to be the easiest. So the least common denominator, which we denote with LCD. So finding the LCD between two fractions, we're going to figure out the smallest multiple that both denominators have in common. Then we're going to rewrite the fraction as equivalent fractions with the same least common denominator. So let's see how we do that in a few examples. So let's perform the indicated operation. So let's say we have 3 11ths plus 4 11ths. So we see that we're adding fractions, so we need to go right to the denominators. These ones are the same, so we're good to go. So all we have to do here is say this is the same thing as 3 plus 4 over 11, so 7 over 11. Okay, and then for the next one for B, 5 twelfths minus 11 twelfths. Once again, same denominators, we're adding or subtracting, so we're good to go. So this is 5 minus 11 over 12. So 5 minus 11. 5 minus 11 is going to give us a -6. So -6 over 12. We can simplify this a little bit. We can simplify it because they have a common factor of 6 that cancel, and we'll be left with -1/2. Okay, next one. Next one we have 5 1/4 minus 2 3/4. So when we're adding and subtracting mixed numbers, technically we don't have to convert to improper fractions, but in my opinion, just do it anyway. It's going to be easier. Okay, so 5 1/4 as an improper fraction. 4 times 5 is 20, plus 1 is 21 over 4. And then the second one is going to be 4 times 2 is 8, plus 3 is 11. 11 over 4. Now they already have the same denominator, so we're good to go. So it's going to be 21 minus 11 over 4, which is 10 over 4. We can actually divide off a common factor of 2, and this would give us 5 over 2 when we simplify it. So a couple more here. So 1/5 plus 3/4. Okay, so now it's a little bit harder. Now we're adding fractions and we don't have common denominators. So we need to find the least common denominator, which means the least common multiple of 5 and 4. So if you have to write out some multiples, let's do 4. So multiples of 4, starting with 4. This is just saying 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on. Hence the word multiple, you're multiplying it by whole numbers. Or you can just do repeated addition where we keep on adding it. So 4 plus another 4 is 8, plus another 4 is 12, plus another 4 is 16, plus another 4 is 20, plus another 4 is 24, and so on. So let's check the multiples of 5 now. Multiples of 5, 5, 10, 15, 20, 25, and so on. So we want to find the smallest one that they have in common. The smallest one that they have in common is 20. So that's going to be our least common denominator. So we need to rewrite each one of these so they have 20 as the denominator. So the way that we do this, we can't just change them to 20. We have to multiply to get to 20. So for 5, in order to get that to 20, we have to multiply by 4. We cannot just multiply the denominator by 4, or else we'll be changing the fraction. So we multiply by 4 over 4. Because 4 over 4 is just equal to 1, so we're not changing anything. So similarly for the 3/4 on the right, we need to multiply by 5 to get 4 to 20, but we have to do it to both the numerator and denominator. Okay, so for that first fraction, 4 over 4 times 1 over 5, that gives us 4 over 20. Second one, 3 times 5 is 15. 4 times 5 is 20. Okay, so now they have common denominators, so now we can add them. So 4 plus 15 is 19. So it's 19 over 20, and that's our final answer. So you need common denominators, and if you're changing the denominator, you also have to multiply the numerator by that same number. So let's say we have 3/4 minus 6. So first I'm going to change 6 to 6 over 1. So these are not common denominators. So we need common denominators here. So the least common multiple of 4 and 1 is actually 4. So we can multiply 6 over 1 by 4 over 4. We don't even have to change the first one. So that's going to be 3/4 minus 6 times 4 is 24. 1 times 4 is 4. So 3/4 minus 24/4. 3 minus 24 is negative 21. Over that common denominator. Can't be simplified, so we're done. And for the last one here, so we have 7/20 minus 4/15. So we have to think about multiples of 15. So multiples of 15 are going to be 15. So this one I had 15, 30, 45, 60, and so on. Multiples of 20, 20, 40, 60, and so on. So the LCD here equals 60. So in order to get both of these denominators to 60, we have to multiply. For 4 over 15, in order to get that to 60, we have to multiply by 4 over 4. And to get 20 to 60, we have to multiply by 3 over 3. So let's multiply these. So 3 times 7 is 21. 3 times 20 is 60. 4 times 4 is 16. 15 times 4 is 60. Okay, so now we have these common denominators, which is what we wanted. So now we can just subtract. So 21 minus 16 is going to give us 5. So that's going to be 5. So 5 over 60. We can actually cancel out a common factor of 5. This would give us 1 over 12. Okay, so 5 over 60 is the same thing as 1 over 12, so that would be our final answer. Okay, so that's actually it for chapter R1.